Okay, this goes with the last video. I want to show you how I made this stove, and I'll break it down slowly and show you piece by piece as I break it down, including how I put in that glass door. There, yeah, that's better for me even. That's the one brick opening from the firebox, and then that's how I position my secondary air tube. Then let's see, yeah. This, you don't want it to rush right out the chimney, you want to block the chimney a bit. Well, the flames in this design, they do hug up the back here. They hug up the back, and then they enter the chimney this way, versus they enter the chimney horizontally is better than vertically. And then I do this effect a lot. It comes up here, goes over and up, and then you can continue this. If you had a high ceiling and you could go up another 100 or 150 bricks, you could make this chimney basically part of the stove itself and heat up an additional 150 bricks. Just, you know, goes here, over, up, over. Just keep staggering it so the gases don't just shoot up, and that way you can heat up a lot more bricks. I'm not sure how clear I was on what I just said. The chimney starts here, so this really serves to kind of block the chimney a bit. Not that the gases are going to directly shoot over if the chimney was just, you know, the entrance was vertical like most chimneys, instead of coming in here. I don't think it's just going to go up and out, but this coming in here and up, this is a blocker. It forces, I mean, the gases want to go up the back wall anyway, but it forces, you know, it forces this motion, this C motion, which is just really for aesthetics, although it is helping heat up all the bricks. And you can see there how I blocked off, it's a little less than one brick. I blocked it off a bit with that metal, just so I'd have all the flame rushing by my secondary air, which I'm still confused why it didn't seem to make a difference. But I only blocked it up for 20 or 30 seconds. Again, the great thing about these real thin stoves of just 2 bricks across is anybody can make any design with no skills, no experience, no lintels, no angle irons, no hard cuts. It's just a piece of cake. And if anybody's saying, well, that firebox is too thin, no, it's not, it's ideal. This is not too thin. That actually creates less smoke. It couldn't be any, I wouldn't go any wider even if I could. Well, depending on the situation. But it's ideal in some instances to have a firebox that's thin. Anybody can just simply create any design just by putting 2 bricks across, and then even the torsion of the bricks, you want to mortar it, but it holds it together, just the tension of the bricks. So I love this 2 brick wide design. And there's some old Soviet designs going back to the 70s that are the same way, called simple stoves, that anybody could build. But their bricks, they use their standard brick is 10 inches. This fire brick is 9 inches. With the 2 brick design, you can even do things like this. Remember, the gases flow. This is the bottom of the chimney, flow on here is the bottom and then up. So you could, I made a change on the fly. I'll show you if I can do this with one hand. Pull this out of here. The heck? Somebody's gunning for me. Pull this out of here. You shouldn't do it like this, but just shows you, you know, I made a change on the fly. And, you know, as long as, see, with a 2 brick design, when you hang your bricks out like this, as long as this goes up high, all this weight's pressing down on this. I mean, you're gonna have mortar too. I don't even use mortar in these tests, but so many bricks were pressing down. You know, I was able to just build on top of this, which really isn't the greatest structural. You'd get an F in your engineering class, but it works. Your bricks can hang out because as you go higher, this pushes down. Okay. Again, this is obvious to many people, but I do this for the novice. Okay, I see why I did this now. I made the change. I was going to have this be the start of the chimney, and just have it, this was going to be the chimney. And that means the entrance, the gases could enter low. I was talking about having them go in on the side versus enter vertically. And I don't know, I just thought a lot of the gases would shoot right over and go up. Instead, I wanted them to go up the back wall. Probably wouldn't make much difference. So I blocked it off because I wanted them to come up the wall and enter this way, enter horizontally. So that's why I did that. But with this design, if you make this the chimney, if you want to extract as much heat as possible, and incorporate the design of a lot of the Russians, of course, you could start your chimney would actually, this would start low. So the gases, of course, it was a little bit bigger. Your gases come up here, hit a ceiling in a box, and then they have to dive down. You don't want to, in this setup, you don't want to go too low, but you just have a 4 or 5 brick opening at the bottom. They'd have to dive down to get to the chimney. It keeps the heat in longer. But again, I was looking for the aesthetics. It still, probably would shoot up the back and look great, but if I remember with that glass door, if my chimney started too low, I'd block my view. Okay, I removed about 40 more bricks, getting to the glass door soon. Take another final look at this. Flames were shooting up good 2.5 feet, I'm sure. And I don't know, with some of you, that's where I put the secondary air. Didn't notice the difference when I plugged it up. You think it should have been closer? I don't know. Probably. This is this is a cheap stainless steel. I don't think it's aluminum. It would have melted. It's got to be a stainless steel, but it wouldn't hold up very long. You need a more. This is just for a test, of course. Need a more industrial strength tubing for secondary air. And it's too wide too. Definitely too big. I know, but it shouldn't. I err on the larger side, not these tiny little tubes that people put in. It's just not enough air. This is too big, I admit, but half of this, yeah, at least. Okay, let's carefully remove the bricks around the glass. Okay. What the heck? Oh, I see. Okay. So, just a regular piece of glass for this test. If this glass was in that flame, it would shatter. Glass doesn't, even though it's created at high temperatures, is only the ceramic glass or pyro glass has different names. This is regular glass. I just cut from I got a Goodwill picture frame. And what was interesting though is, it was far enough away from the heat, or the chimney it entered up here. It's far enough away. It was probably 300 or 400 degrees here. That's not enough to shatter glass. So I just, with a regular masonry blade on a 4-inch or a 4.5-inch angle grinder, I just made these grooves in fire brick halves. And look, the glass stayed very clean. Fire brick halves. This fire brick is very soft, very easy to cut with a 4.5-inch angle grinder, the thin masonry blade, and then just drop it in the slot. If it was a permanent feature, you'd pack all around with that Imperial stove mortar, but and it would, if in other words, if this was ceramic glass or pyro glass, but you need a way to clean it. Like I said in the last video, it stayed clean, but if you used green wood or something, or this got real smoky, this for whatever reason, and it gets smoked up, the temperatures aren't hot enough here for it to clean itself. You need a way to get in there and clean it, or it's all for nothing. That's why in most people that make a stove like this, the top section should be a glass door, so you can open it and clean it. This wouldn't mean much, but if I had it to do over again using this exact same rig up, I'd probably just move it over a bit, put it in the flame, more like that. I mean, big deal, right? It's not going to make that much of a difference, but you get more of that Bertolli effect. The flames ripping right by will suck air through the tube. I don't know if I'm, you know, that effect, whatever. I don't know if it's called Bertolli or what. Just to talk about secondary air in general. All I did was move these bricks out. Remember, these bricks on a 2-brick wide stove, they touch. I just slid them out so they hang off the sides. With, like Lowe's, I know has these, you can make, I guess, shelving out of them. They have, it's more of like a decorative tubing, but it is like wrought iron. It's very, very sturdy, and you know the pieces kind of screw together. You could, again, secondary air tube needs to be preheated, and this is lying on sheet metal. So you get rid of the sheet metal, you get a tube, of a metal tube or iron tube that's much smaller, half of this. You probably, with an angle, remember these touch, you probably could just chisel out a section, maybe like as a V, and then you could just lay your tube maybe in the middle. As long as an inch of that bottom of the tube is in the flame, you're going to get all the preheating you need for secondary air. And the general principle, whether you like this stove or not, forget this exact example, whatever you do for secondary air in any application on any stove, the secondary air has to inject in the small area where the flame is being concentrated. That's the only way it works. Because it was a secondary air experiment, I blocked it off a bit with sheet metal on the side, so my opening was less than 1 brick, and the draft was incredible. You know, it was incredible because the small firebox we talked about in the last video, a firebox of just 4, I can't see what this is aiming at, I hope it's 4 high, creates that rush of air. And that, when you get that quick rush of air, it'll suck through even a small space like the principle behind a rocket stove port. So when I make this firebox taller, I will probably not choke it off in the back, because as you make the firebox taller, your rush of air slows down, and your flame shooting up the back will not be as high, but you know, it's just a trade-off. Why does it doesn't have to be 4 feet like it was. Maybe, you know, just a flame shooting up 2 feet's nice, because now as the firebox gets higher, that air rushing is going to get less and less. So there's people that make rocket stove videos and they say, oh, I don't have any ash, like don't worry about ash clean out. Bull crap. If you have, it depends what you burn. If you burn a briquette, a manufactured briquette, maybe you'll get no ash, but there's always going to be things in any kind of wood that can't be burned, no matter what temperatures. I agree with a rocket stove, it's less, but always plan for an ash clean out, an ash pit. These people with the rocket stove saying, I don't get any ash, check, bull crap, bull crap. You see videos with people suggesting to put all sorts of secondary air or air coming in the back, and it's a waste most of the time because you're just adding air conditioning. You put tubes in the back there, air in the back. You see people with the rocket stoves, or air from underneath, tertiary air. It's air conditioning. It's cooling everything down. If you have a long run like this and your exit out the back, all this flame in here, all this heat, I'm going to take advantage of that. A lot of rocket stove designers use their channels at the bottom and on the top to take advantage of all that heat. Don't poke air holes. Even some of the Russian stove makers, they'll have little squares in this fire brick. A waste, absolute waste. They're just adding air conditioning or adding smoke.